Hello everyone, we are back again with another topic, and today's our topic is Ohm's law. So let's understand what exactly is Ohm's law. Before we go ahead with Ohm's law, I would like to bring it to your attention that till now we have covered the concept of electric current, we have covered the concept of potential difference, what is the circuit diagram, what are the circuit symbols, and we have done all those in detail. So please go through the previous videos and watch, and after that, if you'll come to this topic, this will become very easy and very interesting. So giving you a brief summary, we represent electric current with a symbol I. We represent potential difference with a symbol V. So Ohm's law is basically the connection between these two terms. What Ohm's law says that if the current through a circuit, if you are increasing it, potential difference in the circuit will also increase. Basically, it says that I is proportional to V, provided the temperature is constant. So what exactly Ohm's law says that you increase current, you increase potential difference, and you decrease current, you decrease the potential difference. So if you want greater potential difference, you need to have high current value. So let's understand and let's see what exactly is the textbook definition of Ohm's law. So as mentioned just now, the potential difference across the ends of a given metallic wire of an electric circuit is directly proportional to the current flowing through a circuit, provided temperature remains the same. This is called as Ohm's law. And the circuit which you're seeing on the screen is basically electric circuit for studying the Ohm's law. So I am also going to show you how this circuit can be studied on screen via the help of simulation. Let's have a look at it. And you can see this is the simulation page. I'm going to take you to the simulation page. This is just a screenshot of the simulation page from the site called as OLAB. OLAB, I have made a video on OLAB already. You can have a look at it also from our channel. OLAB is online laboratory. This is designed by Government of India. So before going ahead with VI graph and having more discussion, let's understand and let's see what is there in the simulation. For that, we have to copy this link, which is seen here on the screen. I'm going to share this link in the description box as well. So have a look at it. Let's go to the simulation page. So as seen on the screen, this is the simulation page, and you can see this is exactly from OLAB. You can have a look at it. Online laboratory designed by Government of India, Ministry of Electronics and Information Technology. You can see this gives you a clear-cut indication about how you can perform the experiment. This is also your one of the set practicals for grade 10. This will be part of your practical exams also. So let's try and understand how this works. So what we need to do first thing here is, before we go ahead, we have also discussed in the previous session about various terms and electrical symbols. You can see this is a rheostat, resistor, voltmeter, ohmmeter, battery. And the moment we connect the circuit, let's see what happened. The moment we are connecting the circuit, you can see it also gives us the arrow indication what we need to do. And yes, we can see. So you can see the value of ohmmeter. It shows us 0.17 ampere, and voltage potential difference value is 2 volts. So if I'll just change the value of resistance, which is from the variable resistor rheostat, you can see now the current value is 0.01 ampere and potential difference is 12 volt, which means if I change the value again, so let's say if I increase the current further, you can see I've got current 0.25 ampere and potential difference is also increased. And this simulation page has one advantage, that you can take all these values and actually you can plot a graph. So I have already done all these things. I have actually these are the random values which I have taken and plotted on the graph, but I have also tried the same thing previously on the same page. These are all the values taken from the experimental setup itself. You can see from this setup, you can see from this simulation I've taken 0.33 will get 4 ampere, and you can see 4 volt, and you can see I've drawn the graph and we are getting the straight line. This is called as VI graph, and this is what we were seeing on the screen also. We call it as VI graph. This is a straight line which indicate that potential difference is directly proportional to current, and this will give us the straight line, which indicate this straight line indicate a constant value. Let's understand what is that constant value on the next page. So when we go to the next page, as per the Ohm's law, potential difference is directly proportional to current, and as it is directly proportional, so V upon I will become a constant, will be equal to a constant, and that constant which we have to substitute in place of constant of proportionality is R. So V equal to IR is one of the prominent and very important formula for this academic year, also termed as Ohm's law, formula for Ohm's law, where R is a constant called as resistance. Obviously, when we are talking about it, temperature remain constant, and there are some factors which affect resistance, which we'll talk about it in the upcoming videos. So you can see based on the rearrangement, we can get the formula as V is equal to IR. We can get I is equal to VR, V upon R, or R is equal to V upon I. So coming up to a next page, when we see a funny way of representing Ohm's law, it says that if you are increasing the resistance, the amount of current flowing through a circuit will decrease, and as the current decreases, potential difference will also decrease. So V is proportional to I, basically. So we get V is equal to IR, I is equal to V upon R. So this was all about Ohm's law. I hope you have enjoyed learning about Ohm's law from this video. That was all from my end. If you have any question, do put it in the comment box. Thank you and have a great time. Bye-bye.